Today for our science video, we are going to be creating a convection current. My name is Aiden, and the cameraman right now is Sebastian. And I guess we'll just start reading our script. For this convection current project, we are going to be making a demonstration of hot and cold water reacting to each other and forming a convection current. Differences between conduction, convection, and radiation. While conduction is the transfer of heat energy by direct contact, convection is the movement of heat by actual motion of matter. Radiation is the transfer of energy with the help of electromagnetic waves.
Is that it? Currents are all around us, and it's in the air, it's in the earth, and even in your soup. Convection currents are when movements of a fluid caused by the differences in temperature that transfers heat from one part to another. Convection currents occur in the mantle of the earth. This process works is the magma heated by the core, then it rises to the outer layer of the mantle, then it cools and sinks back down to the lower mantle, and it repeats the process over again.
Now we are demonstrating a convection current.
Hey, talk loud.
Here, as you can see, is one example of a convection current. As you can see, the heat, which is the red, rises to the top because it is less condensed, which means it is lighter. And the blue, which is the cold water, is more dense and more compact, which makes it sink to the bottom. Now for this one, we are going to be putting the cold water on top, showing a different reaction between the two types of water. As you can see in this process, the cold water is on top, and see how in the bottom, you may want to get closer, Desi. As you can see in the bottom, you see how the blue starts to sink and fill into the red and making it darker?
Yeah, because it's kind of dark outside, so it's hard to see.
The heat is now rising into the blue, and the blue is now sinking down into the red.
And that's what makes a convection current.
Yes.
The way convection currents occur in the Earth's mantle is when the magma by the outer core gets heated by the outer core, then it rises to the top by the crust, and then it falls down when it gets cool and gets heated again by the core, which makes the convection current always in motion.
Yeah, and it's like repeats itself over and over again, never stopping.
Never stopping.
1.
For an example of a real-life convection current, we have a hot air balloon. What the hot air balloon does is the fire from the like actual bottom of the air balloon, the heat, the warm air from the fire will heat up the balloon on top, the massive balloon, and fill the air and fill it with hot air, causing it to rise above like up in the air, because the temperature in the balloon, the hot air in the balloon is warmer than the average temperature at ground level where we're at, so it will cause the balloon to rise, making it a convection current.
Convection currents also cause weather. It causes weather by the change in temperature in the air. What happens is when the hot and cold air mix, they can make a tornado or a thunderstorm. The tornado can be caused by convection currents. The car was
For our last real-life demonstration, we're going to be demonstrating our actual, project demonstration. The warm water and hot water reacting to each other.
So over time, the convection current was in process, which created convection current, and the two dyes mixed together because they don't stay apart. And yeah, that's what happened over time.
Yeah, basically, we put the hot water on the bottom to see what it would react to the cold water on top. And as you can see, the dyes mix, but really now the hot water is in the top and the cold water is at the bottom.
Yes, it is.